Welcome everyone to the final presentation of the day. I would like to introduce you to the system we developed, smart training tool for climbing. So in the following slides, I'm gonna give a brief introduction to what it is a campus board. Secondly, we'll present our iCampus board. Next, we are gonna go into the details of the hardware, system architecture, system like software and UEI, and finally, we'll draw some conclusions about our achievements and also draw some outlook for the future. So, for the first time in history, sport climbing is gonna be part of the Olympic sports at Tokyo 2020. We are all aware that at the elite level, especially at the Olympics level, small differences in performance and level of fitness can have a bigger impact. It's therefore important to have a quantitative assessment of the training methodology used by athletes in order to optimize the training. In this particular project, we focused on climbing, in particular a special tool which is the campus board. It consists of wood ledges where a climber can perform different exercises with using his hands and improving overall power.
So we've just heard about campus board, and what we did was something that, well, at least for knowledge, has not been done before, and that's to introduce some quantitative metrics to it. So we're able to measure how the climber distributes their force over time onto the different runs, and also by defining a suitable threshold, we can also define a period and duty cycles, all useful metrics. We achieved this with fairly simple but efficient design, consisting in independent and modular rungs, each attached to piezo-resistive strain gauges. The setup basically allows to determine the total force and the position of the center of mass, as we're saying, and the reinforcement we implemented allows us to support a wide range of climber weights, and we're also able to suppress overload for additional safety. And all that while minimally influencing the original feeling of the campus board. So we passed the electronics part.
The system consists of a set of load cells, and we monitor the voltage variation, and we convert the mechanical signal into electrical and then into the digital domain, where we can process and also control a set of LEDs providing a visual feedback to the climber. And finally, we transmit the data to a PC for further data analytics.
Let me introduce the user interface. We choose MATLAB to make the user interface communicate with Arduino and implement the functionalities. In this region, the users can input the port information and their desired record time and their weight for further threshold detection. After press the button Start Test, it starts to record and storing climbing curves. This status shows the difference between the left and the right forces. It shows the balance of the climbing. It also monitors the climbing curves in the real time. Besides this function, we also can do threshold detection according to the data of the user to obtain the accurate climbing pattern And then we can reply the clubbing pattern for repeated exercise. No matter the user want to follow the clubbing pattern of others or want to follow the clubbing pattern of themselves. According to the way that the user input, two thresholds are set. One is for the raising edge and one is for the dropping edge. When the force reaches the threshold, the moment will be saved in the MATLAB. And then after pressing the button loading, it will be sent to the Arduino. Then after pressing the button playback, Arduino will control the LED slide and on and off. And then the pattern will be played, and the user can follow this pattern to do exercise. That's the kind of feedback of the climbing.
And finally, we tested our device on a subject while executing different exercises. In the first exercise, the climber is stepping one by one. And with our device, we can monitor each phase, so we can get the count of each phase, and also extract some matrices about the timing, which provides some correlation to the rhythm of the climber executing the exercise. In a second exercise, in a similar fashion, we monitor each phase and the timing. And finally, in this particular exercise, we can monitor the peak force difference between the hands while the climber is executing so-called double catches, which means the climber is jumping to the next run with both hands. And by that we can correlate to a shift correlate with a shift of center of mass. And similarly, the timing parameters. So in summary, we implemented a portable system which can be expanded to increase the number of ranks. Pardon? Sorry. And we implemented a customized PCB to extract the data from the sensors. And in the future, we would like the system to be used for a sport study, to collect additional data, and also to evaluate some scientific evidences. Portability will be a plus, especially for coaches. And also, as an ultimate goal, increasing the number of force sensors on the surface will be beneficial, so to increase spatial resolution and extract shear forces and normal forces on each finger while climber executing different exercises. Thank you for your attention.
Hello. Are you thinking about integrating your system into the wooden holes so you can screw the stuff like in the normal climbing gym?
Sorry, I couldn't see you. Can you repeat that?
Okay. Yeah. And are you thinking about integrating your stuff into the wooden holes so that you can screw the stuff into the normal climbing gym?
Yeah, actually, thank you for your question. We consider like a possible future solution, which would be to drill like small boxes underneath the surface, and we could like one option would be to implement like resistive sensors. Maybe like in the future we can also have like a capacitive membrane, and also like with two-dimensional matrix extract like precise points for the mapping.
Yeah, no, but actually besides that, as we are now, we can actually mount it. Originally, we actually mounted it on the wall. This we make a sort of ad hoc aluminum frame for the presentation. And yes, of course, it's also nice because it's portable. But there are different ways to mount it. It's quite flexible.
Wall climb? That's so cool. I actually want to use that also. Wall climb, yeah? Do you guys Can you, yeah, for an indoor, this is the indoor wall climbing, right? So, can you create a little bit more interesting features like we do have in campus? We have all these different variations of
So,
features.
like, as I said in the introduction, we focused on a particular tool. It's not it's not meant to equip a wall like for single holes. And also we recognize it's an advanced training tool which addresses elite climbers. And we all know that they can make like if you can like monitor different parameters like in a quantitative way, because using computer vision you still have the problem of quantifying your results.
Yeah, exactly. Time out? Can we say time out? All right, well, not allowed to continue. I think otherwise Alice is going to make me trouble.